Hello everyone and welcome to the release of version 2.0 beta for Ticker Kinetics. This version has changed quite a bit, and I'd like to thank Bill Michael for his work in trying to make a whole lot of escapements that really weren't possible to make. He went through a lot of pain trying to do it, but it showed me a lot of the errors and a lot of the ways things could be improved. So thank you, Bill. All right, on the screen, what you see is an escapement that I've been working on this morning. I didn't want to hold the release of the beta while I played with it too much because things seem to be working quite well, so I thought I'd release it to you. The program has changed in quite a few ways in terms of being able to draw and extrude your own objects in a program module called SimCAD up in the upper left. SimCAD is a rewritten version of Vex, which has been recoded to do primarily extrusion, but it's also been prepared for a lot of other modules to be added to it. It's been updated quite a bit and works quite well, I find. It allows you to quickly draw something like this escapement on the screen, which I haven't quite completed. It's not yet continuing to tick, although surprisingly enough, it does tick. I think probably the best way to illustrate the changes that are in the program to allow you to do something like this quickly is to start a new project and take a look at some preliminary steps that you would take to start drawing an escapement or a kinetic art device of your own. So we'll do that now and just take a quick look at what can be done in the new version of Ticker. So here we are with a fresh project, a fresh screen, and we're all ready to go. The only thing on this screen that you notice that has changed, two things actually, is this modeling display up in the upper right-hand corner. You can click on a face to go look straight into that face. The blue face is your Z-axis, which is normally facing you. If you click on any side of the model placer, it will rotate to show you the device from that angle. Remember that pressing the Shift key and moving your mouse allows you to pan, and you can now pan in any of the axes. It doesn't care. You can rotate around at will and set yourself up with the axis that you wish to work with. The only other change on this screen is the workbench button, which you can turn off the workbench with in order to get a better look at something perhaps from behind. I like to have the workbench on at the start of a design simply because it gives me a point of context to work with. So let's take a look at what it would take to design something like a gravity escapement right from the start and how I go about it. To go into CAD, all we do is click on the SimCAD button up in the menu, and this will take us to a CAD screen, which, as you'll notice, looks very much like Vex. The size of this gridded work area is the same size as your work table, which you can set in your options. Under the menu options, you can set your work table size. 300 is 300 millimeters on a side, and you can always check to see what size you're in by going to the simulation screen. And whenever you touch something in simulation, this display over in the corner tells you the point that you're touching on an object, wherever it is. So it's a ray being shot through to touch a solid object. And you can see that this work table is going from plus 149 to minus 149. Your work table is always 0, 0 in the center. And the same will be true when you go to the CAD screen. You can see our coordinates in the bottom corner, and we go from 150, 150 to minus 150, minus 150. So this grid basically matches your 3D model table. So let's try to design something to place on that table which looks something like an escapement. So I'm going to start this drawing off with a gear because I'm going to be driving this thing with a weight wheel of some sort, with either a lead weight or with a spring. I don't like motors in my kinetic art. So I'm going to start off by putting a small gear on the screen because you always drive an escapement with a small gear. I'll use a 12-tooth gear because 12 teeth is really the minimum number of teeth one should put on a gear for reliability's sake. So we'll stick with this one, and I'm just going to put it in an arbitrary spot on the screen. I will make two concessions here, though. As I move it around, you can see the coordinates of where I'm putting it on the screen. And I like to put it into an exact numbered coordinate so that in future, if I'm doing some math, I can always figure out what to do with it. So to do that, I can hit the Control key and click on an entry. This is my x-axis, and I'm going to put it on 0 for my x-axis. And then I'm going to hit enter, and then we'll click on the y-axis, and we'll put it at, say, 80. And better yet, let's put it at 60. There, so it's somewhat up on the screen. And we'll accept that. And I'll move it up maybe to 50 in the air, just so that we're in the air hovering and we're not really in anybody's way. And we'll hit accept. And there's our first gear for our escapement. Now, before I go to the CAD drawing, I'm going to make sure that I hit the plane, because I want to look straight in at this gear so that I don't have a perspective problem on my drawing screen. Incidentally, there is a keystroke button, the Alt key. If you press the Alt key, you will go to a temporary ortho display. It'll show you a straight-in display of your mechanism with no perspective distortion. And you'll get 3 displays on the side to show how it looks from the left, right, and top and center. All right, so we have our first gear on the screen. We're going to flick to the CAD screen. And when we do, you'll see that we now have a blueprinted gear at the proper location on our drawing screen. And we're going to go from here to draw something that looks roughly like an escapement. Perhaps we can make it do something. All right, I'm going to zoom in on this gear. And let's draw a shaft hole for the piece that we're going to put on it. We'll draw our ratchet for our escapement. Now, the tools in the program, I should probably explain a bit as we go through, because many of you might not have used Vex in the past. And this would be a good primer for how to use it in any event. So I've drawn a circle on the screen here. It doesn't quite match up exactly with where the shaft is on the other device. This won't matter because it will place onto the other device's shaft once we extrude it. But if we were to be picky, let's look at how the drawing works so that we could make that more exact. At the moment, I have a circle tool selected. You can see the circle is highlighted up in the corner. And there is a context menu on our right mouse click. And it has several selections that you can use. Down here in the bottom, we have undo and redo in case you make a mistake and you want to back up. At the bottom is a gear that you can click to turn on several options, such as a grid, snapping distances, and so on. You can draw reference points or hide reference points. There's all kinds of things that you can do down here, copy, paste, etc. Just remember that this menu is here. It does come in handy, but a lot of the time you won't be using it unless you're trying to set a snap to get some accuracy. So let's center our circle here. I'm going to right-click on my context menu and hit the check mark. When you hit the check mark, if the tool doesn't exist in this menu that you're currently using, the tool will turn off, and you can see circle just turned off. And that means we can go in here and select our circle that I just drew, and it turns red because it's selected. In this CAD program, if you select something which is already selected, it will go into what I call blue motion mode. Everything turns blue, and you get handles with which you can stretch, move, and adjust things. You can grab your object with the center handle and center it to a much better proportion. You can use your arrow keys on your keyboard to jog items back and forth for exact placing. It's very forgiving and a good way to move things around. Now, I should mention while we're on this topic, whenever you're in motion mode, there's an extra dot on the screen. You can see my hand is pointing at it here, and it's gray, which means it is not currently active. This is a rotation dot. And if you grab it, you can drag it wherever you like. For example, I can drop it here in the center, and it turns green. And now if I rotate this object, it rotates on this center. You won't see anything move, of course, because we're currently rotating a circle. But if I was to move the dot up there, you can see we rotate on its center. This is a very powerful feature for testing kinetics, and we'll talk a bit more about that later on as we begin to test some things. Clicking on a rotation dot again to turn it gray will turn it off, and at that point objects will rotate and scale from their barometric center, or the center of the object, which was always the center handle that you used to grab it with. All right, so we have a shaft hull for this device, and we have a button up here, set unset shaft. If you select any circle, and it has to be a circle, and click it, it will tell the system that this isn't just a hole through whatever you're making, it's an actual shaft. It turns green. If I select away from it and select it again, you'll see the shaft turns green, telling you that you have set this as a shaft. Keep that in mind. It's important in future when you're placing things. All right, so let's draw a gravity ratchet on here. What I'll do is I'll go to my line drawing, and I'll go straight up from center. And the system will lock in important areas like center. You'll see it says CC on the screen on my mouse cursor. I don't know if your video will show that, but it actually says CC when you hover over a center. Let's draw a line, and it can be of arbitrary length, but let's take it up to here. And I'm going to then turn off this tool, and because I'm using a tool which is in the menu, I can click on that tool again to turn it off. I'm then going to go to a 3-point arc, click on the top line, click an arbitrary spot here away from what I'm doing, and just give ourselves a little curve. And turn that off by clicking on it. Okay, I'm now going to select, and I can drag a selection box if I like to select that complete line. And then I'm going to click it again to put it into motion mode. And now my rotation dot is up here, and I can grab that and drop it right down here at the beginning of that first line, which is 0, 0 on that gear. And I'm going to select circular array, and I'm going to tell it how many turns in a sweep angle of 360 degrees I want. And in this case, I'm going to tell it I want 4 copies. And we get 4 copies of those lines. And if we now draw a circle from the center out to a good distance for a hub, we now have pretty much a device that can be extruded if we just simply snip away the lines which don't belong. The snipping tool in this program is very powerful. I think that most of you will like its operation. It automatically can figure out what is touching what and what is intersecting and create an object. So here we've created our first object. I can right click and turn off my scissors. And if I select this object, the extrude button will light up on the screen. We've already set a center shaft. You notice the shaft light is lit because it senses one of the objects in there is a shaft, and I'm going to ask it to extrude. The only question you'll be asked is depth of extrusion. Remember, everything in this program is in millimeters, so I'm going to ask for a 5 millimeter thick device, which looks like this. And when I push OK, we go to create a hull. Remember from previous videos, every object should have a hull on it. We can look at this object from any direction to see how well it extruded. If it didn't extrude well, you might want to go back and make a drawing modification. I'm going to hit Generate Hull. You can see it created it very quickly, and if we zoom in, you can see convex hulls were created all over it. We have nice sharp angles. You should always check the quality of your hull to see if it's good enough for you, because the quality of your hull really depends on what you're drawing. Sometimes you want the teeth to be crisply delineated. Other times you wouldn't care. Really is a use thing. And now I'll say create. And when I tell it to create, it took the information from the drawing where I drew it over the shaft of this object, but it has no idea as to Z depth because our CAD program doesn't have a Z depth, but it did put it in the right location. In our case, we're going to select that axle, that shaft, and we're going to move it up the shaft so that it's connected to that gear, and accept it. And there's our first object. It is the ratchet for gravity escapement. If we wish to test it, we could, for example, turn on a motor, go to simulation, and tell it to go. And this would be the motive force that tries to drive our escapement. If it was to hit something, it would stop. And that's basically how our escapements are powered. Rather than putting an actual string and a weight on them. We give it a motor power, and if it hits anything, it'll stop. So from here, we would start to draw the rest of our escapement. So I'm going to stop this, and we're going to go to our modeling screen, because the next point you have to be aware of is if you look at this cube, you can see other faces are showing up, and that means we're not actually facing directly into the screen at the moment. It's important that you do so if you're using blueprint mode, because otherwise when you extrude, if I were to go to the CAD screen and draw something, when it extrudes, it would extrude on this plane, which is not straight in. If I click on the face, you can see we straightened out a bit. Now we're on plane and we can go back to SimCAD. So now in SimCAD, I can take this drawing and drag it away for storage. You have a wide area of storage. You can just shove a drawing up in the corner and say, I'll come back to it later. And now our blueprint shows that we have two parts of our escapement ready to go, and we can begin to draw from there. All right, I'm going to drag this escapement back, or this ratchet back. So put it back on 0, because it does come in useful for simulation purposes as you're drawing. And I'll just stick it right on top of where it was. All right, so for the next part of our drawing, we're going to want something which the teeth of this particular ratchet strike and get held to create energies. So let's try to create something to match that. I'm going to draw a line straight up to about where I want to begin my pallets. And then I'll draw a circle at the tip of a line. One of the important things in Vex is if you are drawing something and you point your pointer within snap distance of an end or a point on the drawing, it will automatically snap to that point. Another point here is you'll notice as I'm drawing this circle, it's telling me radius and diameter in a little float window. These are entry windows, which you can use. I'm going to hit Tab, which shifts me to the diameter window, and I'm just going to type 5.0 and hit Enter. And when I do, it will complete that circle for me at 5 millimeters. So the circle I just drew is going to be the shaft which holds a pendulum, which is going to swing left and right here. And I want to be able to use that pendulum to trip a pallet to release this ratchet to turn. And in a physics simulation, you basically want a 90-degree angle from your ratchet tooth to the pivot point of whatever your pallet is on. For example, if we want to hang a pallet off of this shaft at the top here, we would want to make a 90-degree angle with this flat part of the tooth, which means, and this is another handy aspect of the rotational feature of SimCAD, if you grab our rotation dot, stick it on center of that object, we can now rotate this to get an idea of the positions that we might want for a pallet. Now you want a 90-degree angle from the hanging point of a pallet to this tooth on its release trigger. So you would want your ratchet to point at an angle of approximately here, so that whatever your locking pin was, it's 90 degrees from here to the tooth. In our case, however, I want as little slip as possible, so as an experiment, I'm going to go straight up from this tooth for our release pallet pivot. So I'm going to draw another circle here, and I'm going to hang a pallet directly above that tooth pretty much. I'll hit my tab key and enter 5 millimeters for my shaft. Let's draw a larger circle to use as a boss. And let's draw a line from the center of our object all the way down. And this will be our release pallet. And I'll draw the line straight down at 90 degrees. Cancel it with that. And let's offset this with offset contours. All of the tools in your operations menu operate on whatever you have selected. In this case, I have this line selected, so if I select offset contours and tell it to give me a 3 millimeter offset all the way around, I will end up with a 6 millimeter thick object, and this will be our pallet arm. So we'll take our trimmer, we'll trim out the center, we can trim out these areas, And now we've got a fair pallet. Now on top of that object, we're going to want to put a shaft as a trigger, which holds that pallet still. So I'm going to just put a pin here, and since I like to use 5mm shafts, let's put it at 5mm. You'll notice that's not very well centered, so I'll cancel this operation. I'll double click on that and I'll just center that onto our beam. And then I will select the entire beam by dragging a box around it, and we'll just move it over so it's sitting right on top of the pallet and keeping it from moving. And now we have to define shafts for the system. Now the last shaft you set will become your main shaft of the object you're creating. So I'm going to click on this shaft and select it and turn it on as a shaft. And then the last shaft I select will be the one which dictates where 0, 0 is on my object. So I'll set that as a shaft. And now I'll select that entire object and we'll extrude it. Depth of extrusion 5. And now we need to create a hull. Now we know that the object's centered properly because the upper hole is in the center of the screen, and that's a good thing. That's proper for it. We'll generate a hull. As you can see, it's very quick. And then we complete the object creation. And when I do, the object is already sitting approximately in the spot that we want it to sit in. So I'm just going to accept it. And now, before I do the final acceptance, because this is the screen on which we can move our object up and down, I'm going to turn to the side here and just make sure that we put our object in a position where the pin coming from the arm can hold the ratchet. And that looks like a good spot, so we'll accept it. And you can see a pin appears, or a shaft appears, because we told to push a shaft there. It's not as long as we might like. So I'm going to click on the shaft. And when I do, there are two selections here, override minimum and override maximum. Override minimum moves it outwards from the screen, and override maximum moves it inwards. So I'm going to override the minimum on this. And as I move it, you can see the shaft moves. So I'll turn this sideways, and we'll move our shaft so it's just above the gear. And that looks like a good position. Double clicking will always take you to a straight in view. You can turn off the workbench if you want a clear look at how things are meshing up. And if we change the material of one of these, we might be able to see this clearer. So let's make this blue, for example. There. Now we can see when we look at it that if we were to tell our ratchet to move, it will now hit this pin at a 90-degree angle to the pivot, which means that there shouldn't be sliding action. We should be able to control that. Now remember that your shift key with your mouse can move your object and pan it around, so you can pan it to center so you can look at it. Let's try simulating this and see what happens. If we go to simulation and hit go, you'll notice it just keeps on turning, but we haven't turned on collisions. So let's stop that, turn on collisions, and tell it to go. Now you can see a lot of things go on. This gear has not been told to keep an orientation, so it's free to pivot around in space on an infinitesimally small line. So let's start by giving that object a orientation lock. And now you'll see when the object comes up and hits the pin, it just pushes it inwards. This is something I guess we could expect because it's not likely that you're going to get a perfect hit on this pin. As you can see, even when I drew it, I placed it just a little bit high, which means that when it comes up, it's going to hit this and it's going to be at a slight angle, which will cause this to sweep inward. On an escapement, you want to get that as exact as you can to 90 degrees on that plane. So let's see if we can do that just by moving it. Again, this is a mythical escapement that it's probably never going to be built. Let's go translate on plane. Will allow us to shift this thing around in the X, Y, and Z. And if we look at it, we're a little high in the Y. So I'm going to slide this down and see if we can get it very close So it's almost touching, and this should make it better. So if we do a simulation here, we can see it is much better. We still get some motion from various forces acting on this thing. If we turn on SimSnap, oh, there we go, we slipped. So we're still not at a perfect 90-degree angle, but what I wanted to do here was show you the method that it takes to draw an object, extrude the object, and create your own mechanism. Now let's take a look at that in mind with a project that I was doing earlier today that is actually workable. And here's an escapement, which is a type of gravity escapement. You can see there is a cam block on top of the 4-pin ratchet. And my surface where I'm going to hit the pins is at 90 degrees to the pivot pin. When this pallet pushes out, this pin will slide forward to hit this pin, which will lock it there, and during that time this cam will push this pallet outwards. The way these gravity escapements work is actually a cocking mechanism. The cam cocks the pallet outwards off of its gravity center and holds it there until the pendulum comes and grabs it, at which time that cocked energy is added to the pendulum, and that's what keeps us swinging. If we take a look at that as an extruded object, you can see it here, and we hit play, it won't quite tick. And I think it's because these two bars at the bottom are a little far apart. But if I pull that out to start it, you can see that it wants to go. And this is a project that I'll continue on, and perhaps we'll see it again in another video. Most of the tools in the new CAD module are self-explanatory. You can turn blueprint mode on and off if you don't wish to have it interfering with your drawing. You have rulers and fillets and all the various pieces and parts that you might need to do a fairly complex drawing. Extruding it is fairly simple. So the thing to take away from here is the way you set a shaft. The final shaft that you push this button on will become your central shaft, the placement shaft. The other shafts will be added simply as slave shafts once you drop them on the screen. All right, that's it for this video. I hope to do another one very shortly to illustrate more how these things work. Give beta 2 a try and let me know what you think. Thanks.